So this is the first video for Core 1 from June 2010, and it's a pretty straightforward question 1. With A, we are being asked to find the gradient of AB, which is this line up here, this line coming there. We have to find the gradient of that line, and we get given its equation, so we'll use what we get given. So 2x, let's start up here, 2x plus 3y is equal to 14. So what we're trying to do with this is get this y here, get that in isolation on its own, get that on the left with nothing else on the left, and then make it so it's not this 3y anymore, so it's just 1y. So how can we do that? Well, we can bring this 2x across to here by taking away 2x from both sides. So if we take away 2x from both sides, then we're going to get 3y is equal to 14 minus 2x. So the next thing we need to do is get this 3 out of there, so we just get a single y. So let's divide by 3. If we divide everything by 3, so we get y equals 14 over 3 minus 2 over 3 amounts of x. And then we have our answer. Our answer, we'll do it in a new colour. Our answer is this here. What is in front of the x is our gradient. When we've got y on its own, then this here, this is our gradient there. And then just, I know the question isn't asking for it, but this here would be our y-intercept. So somewhere up here, this line would carry on, and then that there would be 14 over 3. But never mind that. So minus 2 over 3, so you've just got to put at the end for the marks, gradient is equal to minus 2 over 3. So let's move on to B part I, part 1. So find an equation for the line DC. So how do we do that? Well, the point D has these coordinates here, and DC is parallel to AB. So what can we say about that? Let's draw a line under this. So for B part I, so we can say that the gradient of DC is going to be the same as the gradient for AB. So this 2 over 3 here, that is going to be exactly the same for DC, and we get given a point. So if we use this, you've probably seen this before, y minus y1 equals mx minus x1. So let me explain what that means if you don't know what it means, if you haven't seen it before. So y1 and x1, they are a point on the line. So you have a point like this, like D here, we've got 3, 7, so 3, 7. So our point there is x1, y1. So x1 is 3 and y1 is 7. So we can plug those straight in. And then what we have as well is m, which is the gradient. So what it means is, if you know the gradient of the line, and you know one point on the line, like 3, 7 there, then you can figure out the equation of the line, which is what they want. So let's do that. Let's go y minus y1, which is 7 there. So y minus 7 equals our gradient, which is the same as what we found out for AB because they're parallel. So minus 2 over 3 of x minus, and then x1 is 3 from here. So the line goes through the point D, and it has the same equation, the same gradient as AB, which we worked out earlier. So let's just simplify it now. Let's times out the brackets first, I think. Y minus 7 equals minus 2x over 3 minus minus 2 times minus 3 is going to be plus, and then 6 over 3 is going to be 2. So then what can we do? Well, we can add 7 to both sides. So let's do that. So then we get y equals minus 2 over 3x, and then 2 plus 7 is going to be plus 9. And I think that is the right answer. I mean, we could go further. We could times everything by 3 to get rid of this this kind of ugly fraction in there, but we don't need to. You don't need to do that for the marks necessarily. Sometimes they'll say put it in the form ax plus by plus c equals 0 or something like that, and then you have to do it the way they say, but in this they didn't, so we can just leave it in whatever reasonable form we like. So let's get cracking with the next one. Let's start with this angle BAD. So this one here, this angle A in green there, that is a right angle. So let's put a little square on it. That is a right angle. So find the equation of the line AD. So we're now going up this kind of bold line up here, giving your answer in the form. See, there you go, in the form. So that's the form that they want it in, where all of these are integers. So they don't want any fractions, is what they're saying there. So we can do that. If this is a right angle, if this angle here, if that is a right angle, then it means that the gradient, let me write this down here, so part II. So if the angle is a right angle, then it means that the gradient of AD, let's write this down, the gradient, it's a right angle, then the gradient of AD is equal to minus 1 over the gradient of AB. So, I mean, you can try and find out why that works by reading through a textbook and whatever, but if you're just doing exam preparation, then the gradient of AB, put it under there. So what that means is we've got a minus 2 over 3 as our gradient for AB. So what it means is, you can kind of remember it like this if you want. This is kind of awkward to remember, maybe. So we've got minus 2, let me undo that, minus 2 over 3. So what you can do is take away the minus for a start, so you get 2 over 3, and then flip it round, flip them over, so you get 3 over 2, and that is our gradient for AD. That's our gradient. So you can memorize it like this if you want, with the minus 1 over this, and then you put minus 2 over 3 into here, and then you bring it on the top and flip it round and put the minus. Or you can just say times it by minus 1 and flip it round so that, you know, like this. I think you get the idea by now. So we have the gradient for our equation of the line AD. So then we need a point. Well, luckily for us, we have a point. We've got the point D up here. So let's do the same as what we did earlier on in part BI or part B1, and use exactly the same thing. Let's draw a line under this here, and I think we'll go for blue. Let's go for blue. So y minus y1 equals mx minus x1. So our y is just y, y1 is the same y1 as we had before, which is 7, is equal to 3 over 2 times by x minus our same x1 from here, which is 3. So then let's simplify it out the same way that we did before. So y minus 7 equals 3x over 2 minus, is that 9 over 2. So now we have to get it in a form with integers in it. They've asked for integers, and they've asked for everything to be on the left hand side with a 0 on the right. So I suggest what we do, you can do it a number of ways, but what I suggest we do is times everything by 2 to get rid of these fractions on the bottom. I'm going to run out of space here, I think, but never mind. So let's say 2y minus 14 is equal to 3x minus 9, and then I'm going to go up here to keep going. Hope you follow me with that. So 2y minus 14 equals 3x minus 9. So what can we do? Let's add 9 to both sides to get rid of this. On here we're trying to get everything onto the left hand side. So we've got 2y, and then minus 14 plus 9 is going to be minus 5 equals 3x. And then what we can do is take away 3x from both sides. I hope you're following me with this. So let's go for purple again. So if we take away 3x from both sides, then we're going to get minus 3x plus 2y minus 5 is equal to 0. And then kind of to make it neat, you don't have to do this, but you can do to make it a bit neater. What we can do is times everything by minus 1, so your final answer will be 3x minus 2y plus 5 is equal to 0. I've gone a little bit over there, but never mind. This is what your final answer should look like, or this one up here. I mean, it doesn't really matter very much, but you know, to try and be neat, try and go for the one that looks kind of the nicest. So, right, question C. I have completely run out of space. I've run myself out of space. Let's see if I can erase some of this up near the top. Let's take out these two questions. Let's get rid of those. Right, back on my pen. So question C. Question C. We get told the line BC, so this line running up here, this line that we haven't used yet, has this equation. So find the coordinates of B. Right, so let's write down that equation. So we've got 5y minus x is equal to 6. That is one of our equations. Now, what we want to do is find out this point here, this point of intersection between this line that we just got given and AB, which we actually got given right at the beginning. So where those two lines intersect is going to be where the point B is. So let's do some simultaneous equations, and we can find out where B is. So it equals 14. Right. So let's label this. This is going to be my number 1, and here we go, purple again. This is going to be my number 2. So how can we get, I've done it kind of, you know, this should be really over here and this should be really over here so that we can look up and down at them, but hopefully you follow me through this. What can we do so that we eliminate either the y's or the x's from one of these? Well, I think if we take number 1, times it by 2, then we're going to get a minus 2x in there, and then let me undo that. We're going to get a minus 2 in there. You can just imagine the minus 2, and then add it to number 2, then we're going to end up with 0 x's, so plus number 2. So what do we get if we do that? Well, here we are. So 5y times 2 is going to be 10y plus 3y, so we're going to have 13y, and then minus 2x plus 2x, so 0 there, they cancel out, and then 6 times 2 is 12 plus 14. 12 plus 14 is going to be 26. 26 there, and then we get, if we divide by 13 on both sides, we're going to get y is equal to 2. So we can already say the coordinates of B, we're going to have some x, and the y, we already know that is 2. So let's try and find out what x is going to be by putting y equals 2 into one of these. For example, number 1, you can choose any of them, but for number 1 we have 5 times 2 minus x is equal to 6. So then we play around with it until we've got x is equal. So we have 10 minus x is equal to 6, and then add x to both sides, so 10 is equal to 6 plus x, and then take 6 from both sides, so 4 is equal to x. So then we have our coordinates for B, 4, 2. And that is all the questions in number 1. I'll see you on the next video.